Hello everyone. The title of this video is Section 7.1 Part 1 on the domain of rational expressions and simplifying rational expressions. In this video, I'm going to be going over a version of the Knewton Alta homework for Section 7.1 Part 1. Please understand that this version of the assignment I'm going over, the questions I see, are not necessarily going to be the exact same questions you see when you work on the assignment on your own. But the objectives will be the same, the kinds of questions I'm seeing will be similar to the ones you see, the way I work on my questions will be similar to the way you should be working on your questions as well. So I'm hoping that watching this helps you out in some way when you're working on the assignment on your own. One thing also I'd like to point out that I don't think I have been recently. When I bring up a new question, try pause the video and try to work on that problem on your own first before you watch me do it. Because if you're just watching me do things and not writing things out for yourself, you're more than likely not going to learn much of anything. So try practicing it on your own first, and then watch me do it, and compare the way you did it to the way I did it, and see if you can learn anything from your mistakes, or see if you got it right in an alternate way than I did, and maybe you'll get a good idea as to how much of the material you're actually grasping. Alright, so here's the assignment page. Now you will not be seeing the words preview of. You'll just see the title of the assignment, the mastery bar showing you how far along you've gotten, the objectives. Now there are 2 objectives for this particular assignment. Your questions. There's a feedback button at the bottom of each question where you can send Knewton feedback about a question, the way it's worded, or if there are errors. You will not be seeing the instructor cheat button. Alright, that's just for instructors. But you will be seeing a more instruction button, which I would recommend you use if you're having trouble with a particular objective or a particular question. You click on this button and some reading material or videos will show up that may help you working on questions related to that objective. Alright, so the first question is on the objective simplify rational expressions, or simplify fractions. Alright, a rational expression is a fraction in which the numerator and denominator are both polynomials. Alright, and I'll write this one out and talk about what I'm doing when I'm asked to simplify a rational expression. Alright, so here we're given the rational expression where the numerator is 216 times a to the 3rd power minus 8 divided by, and your denominator here is 36 times a squared minus 24 times a plus 4. Now, to simplify a fraction, to simplify a fraction or a rational expression, the first thing I'm going to do is factor the numerator and denominator of the rational expression completely. So factoring. Now I'm going to be assuming here, since we're in section 7.1, chapter 7, and we've done the chapter 6 stuff before, I'm hoping you've seen that. I'm assuming that you know how to factor polynomials completely. Alright, so the numerator, so I'll start with the numerator here. We have 216 a cubed minus 8. Now the greatest common factor, right, the first thing you should look for when factoring is the greatest common factor is 8. 8 goes into both these terms, so I'll pull 8 out. And you could even break up 8 to 2 to the third power, right, 2 times 2 times 2, but I'll leave it as 8 for now. And then what's left over when I factor out 8 would be 27. Right, 8 times 27 would be 216. Right, that'd be 160 plus 56, 216. 27a cubed minus 1. Now I'm looking at this 27a cubed minus 1. This is actually a difference. I'll just put diff. It's a difference of cubes. Right, 27a cubed is really 3a to the third power. Right, 3a times 3a times 3a would be 27a cubed. Minus, and then 1 is 1 cubed. You can always put 1 to any power to make 1 again. Alright, so again, I'm hoping you remember how to factor polynomials. So this is 8, right, that factor of 8 I pulled out. And then a difference of cubes. Remember, a cubed minus b cubed factors to a minus b, so 3a minus 1. Times, and then a squared, so 3a times 3a, 9a squared, plus ab, 3a times 1, so 3a, and then plus b squared, or 1 squared, which is just 1. Alright, so there's the numerator, totally factored. And this factor here, the 9a squared plus 3a plus 1, yes, this is a quadratic trinomial. So you might try factoring it with the AC method, but there are no factors of 9 that add up to 3. So that's as factored as that's going to get, right? So there's the numerator, totally factored. Let's look at the denominator now, right? 36a squared minus 24a plus 4. And same thing, first thing I look for is, do all the terms in the polynomial have a common factor? And in this case, that common factor would be the number 4. 4 gets pulled out, and what would be left over would be 9a squared minus 6a plus 1. And you can factor this with the AC method. Again, I'll leave it to you, but I'll just tell you what it ends up factoring to. This would be 4 times, and then 9a squared minus 6a plus 1 factors to 3a minus 1 times 3a minus 1 again. So you don't need to write the same factor twice. Just, if you see multiple factors, the same factor over and over again, you just write exponents. So this factors to 4 times 3a minus 1 to the second. Alright, so this fraction, the numerator is 8 times 3a minus 1 times 9a squared plus 3a plus 1. Alright, that was the numerator, totally factored. The denominator, totally factored, is 4 times 3a minus 1 to the second. Alright, or times 3a minus 1 times 3a minus 1 again, if you want to write that. Alright, so that's the first step. Alright, factoring the numerator and denominator completely. Alright, then what I like to do next, they're not asking me to do, but I like to do it. I like to state values I like to state values that the variables cannot take. State values that variables cannot be replaced with. So remember, the denominator of a fraction, right? The denominator of a fraction can't be 0. Right? That's huge. Because if the denominator of a fraction is 0, that means you're dividing by 0. Division by 0 is undefined, has no value, meaningless. So if you look at the denominator, right, and the denominator only, you have this factor of 3a minus 1. So off to the side here, I'll make a note that the value of a can't be 1/3. Alright, and I'll just keep that in mind. This isn't the answer. This isn't the final result. This isn't what they're asking me for. But I'm just going to keep this in mind, because if I were to replace a with 1/3 in this expression, the denominator would be 0, and that's bad. Alright, so now that I've factored the numerator and denominator completely, I've then stated values that aren't allowed to replace the variables, values that'll make me divide by 0. Then I will divide out any common factors. Divide out or cancel, right, any common factors that the numerator and denominator have, right? Any common factors of the numerator and denominator. So looking at this, now you could break down 8 and 4 some more if you wanted. 8 is 2 to the third, 4 is 2 squared. But you notice that there's 4 is a factor of 8. So 4 is a common factor. 4 cancels here. 4 would cancel here, but 8 is 4 times 2, so I'd be left with a factor of 2. I'd be left with a factor of 2. Then the only other common factor I'm seeing is there's a factor of 3a minus 1 in the numerator, and there are 2 factors of 3a minus 1 in the denominator. So only one of those will cancel. So I'm not going to cancel the parentheses 3a minus 1. I'm just going to cross out the power and change it to the first power. Right? We're just noting to myself that one of those factors is still remaining. And there we have it. Right? So this is equal to numerator is 2, has a factor of 2 left over, times the quantity 9a squared plus 3a plus 1. And the denominator has only one factor remaining. And if it's the only factor remaining, there's really no need for parentheses around it. It just has the 3a minus 1 factor left over. And there you go. This is what they're asking us for. The simplified fraction. Now if you want to test some values, this could be, I guess, the 4th step. Test some values. Look at the first, go back to the original and replace a with any value you wish. Right, replace the variable a with any value except 1/3. Right, remember I said that earlier, a cannot be 1/3 because that'll make a denominator of 0 throughout the problem. Right? Anytime throughout the entire problem, if there's a denominator of 0, that's not good. And see, well, how about if a were 0? Right, if a were 0. The first expression, the numerator would be -8. Right, so I'll look at the original expression, and I'll look at the final expression after simplifying, and we'll see that they have the same value. the original expression, the numerator would be negative 8. The denominator would just be 4. So this is negative 2. The final expression, you'd have 2 times 1 in the numerator if a were 0, divided by, and then 0 minus 1, negative 1 in the denominator, which is also negative 2. They have the same value. So that's good. And it should be that way no matter what you plug in for a. Right? No matter what you plug in for a. The value of the original expression should be equal to the value of the final. And it won't always be negative 2. Right? The value won't always be negative 2. Just whatever you plug in for a, the value of whatever the value of the original expression takes should be the same as the value of this final expression. Right? Now, the way I have it here, the numerator is still factored. You could also multiply everything out if you wanted. Right? So if I actually multiply the factors in the numerator, distribute the 2, we'd have 18a squared plus 6a plus 2 in the numerator, and the denominator is still just 3a minus 1. Right? And this is equally valid. Right? In fact, this is what I'll enter. Right? Yeah, I'm sure you can enter either one, and it'll take it. Right? So going back to the assignment here, I'll enter that final fraction of, make sure I would put parentheses around the entire numerator, just so it knows when you put the division symbol that that's the numerator. Or you could do this. There should be a fraction bar here, something where you can enter fractions like this thing here. Right. But I just put parentheses around my numerator. 18a squared plus 6a plus 2 in the numerator divided by, and then denominator is going to be all below the bar there, 3a minus 1. And you can go back and erase the parentheses if you don't like. You don't have to. You do not have to erase the parentheses. That is totally fine, but that's a little cleaner looking. Great. All right. And then after every question, whether you get it right or wrong, there's an answer explanation. Please read this if you got it right or wrong. Right? If you got it right, read through it and make sure you got it right for the right reasons, that you didn't just get lucky. Or maybe they'll provide you an alternate method for something. Now, if you got it wrong, especially read the answer explanations, because hopefully you can read through and try to figure out where you went wrong, and maybe you can learn from your mistakes and do better on future questions related to that objective. All right. Next question. Now this question's on the objective. Determine which values make a rational expression undefined. Now, I've already kind of pointed this out with the first question. Remember, a rational expression will be undefined whenever the denominator is 0. So what we're looking for questions in this objective are values of the variable, values I could replace the variable with, that would make the denominator 0. So for these questions, I'm really only going to be focusing on the denominators. Alright, so I'll write this out, and again they're saying determine the value or values for which this fraction, this rational expression is undefined. And if there's more than one value, just separate them with a comma, right? So here your z equals, what values of z make the denominator 0, make this expression undefined. So here is the rational expression we're given. Remember, this is undefined. It has no value when the denominator equals 0. So basically we're solving this equation. Right, trying to figure out where the denominator was equal to 0. And this goes back to section 6.5 on solving polynomial equations by factoring. Right, so look, so I'm only focusing on the denominator. When is 6z squared plus 14z minus 80, when is that equal to 0? Alright, now one thing I'm noticing is that all the coefficients here are even. So first I'm going to divide both sides by 2 just to make the numbers a little smaller. So if I divide everything by 2 on both sides, we'll have 3z squared plus 7z minus 40 equals, and 0 divided by 2 is still 0. Right? So equation with some smaller numbered coefficients. That's the only reason I did that. Well, it's already kind of set up the way I want. I've got everything on one side, 0 on the other. It's got to be 0. And then I want to get a completely factored polynomial, right? I want to eventually write a product equal to 0. So that way I can use that 0 product property to help me find solutions. Alright, so we factor, I want to factor this polynomial completely. So, I mean, again, you can do the AC method, guessing and checking, trial and error. But I'll tell you right now, I'll just write out how it's going to factor. I'd have to have 3z in one factor and z in the other to get 3z squared. Then the other two parts of these factors need to multiply to be negative 40 in such a way that when I distribute, I end up with positive 7. All right. So let's see if I break this up to, negative 8 and positive 5. I would need negative 8 here, positive 5 there, right? That gives me 15z minus 8z for the positive 7z. And then negative 8 times 5 makes negative 40. Again, you can do the AC method and factor this by, break it up, rewrite the middle term and factor by grouping. Again, I'm hoping you already know how to factor. Alright, now I have what I want, a product equal to 0. So by the 0 product property, which I'm assuming you know, which I'll also abbreviate as ZPP for the rest of the video, the only way a product is equal to 0 is if one of the factors is 0, at least one of them. So either the factor of 3z minus 8 equals 0, or this other factor of the polynomial, the factor of the product, z plus 5 equals 0. And solving each of these gives me the solutions of the equation, and those will be the values that will make the denominator of this fraction 0. Those will be the values that make this expression undefined. So this first one would be z equals 8/3. Just add 8 divided by 3. And check it, make sure it makes that expression 0, and it should. And this one, z equals negative 5. And again, don't forget to check it back in the equation here. Both of these values will make this denominator 0, and therefore the expression undefined. Right? So back in the assignment, those are what I'm putting in with, with a comma separating them. 8/3 for z makes the expression undefined, comma, and then negative 5. All right. Again, please read through the answer explanations. Next question. All right, so we're still in this objective. Another question. Determine which values make the rational expression undefined. So it's the same deal. I'm given a fraction, a rational expression, and all I'm concerned with now is figuring out what values of x would make the denominator 0. And then, those are the values of x that I couldn't plug in, right? Because you can't divide by 0. All right, so once again, given a fraction here, and I'm not concerned with the numerator at all, right? We want to know where, for what values of x will the denominator be equal to 0, solving this equation. And then those values of x are values I couldn't plug in. Right? They won't be in the domain of the expression. Right? Domain of an expression is just all the allowable values of x. So we're trying to find the unallowable values right now. All right, so again, just the denominator, negative 30 times x squared minus 25 times x, and then plus 5 equals 0. And one thing I notice again here is that all these coefficients are multiples of 5, and the lead coefficient is negative, so I want to make that a positive. So what I'm going to do is I'm going to divide both sides. It is an equation, something equals 0. I'm going to divide both sides by negative 5. That'll make this positive 6x squared, then this positive 25x, 5x, positive 5x, and then negative 1 equals, and then 0 divided by negative 5, right? 0 divided by any non-zero number is 0. Alright, and then I'm factoring this quadratic trinomial here. Again, you can use the AC method, but I can already see how it's going to be factored. So I'm just going to write the factors, right? I'm assuming you already know how to factor too. Right, so I would have to have 6x in one of these, x in the other. Now again, you could have 3x and 2x, but again, you can do guessing and checking, trial and error and whatnot. And then I'd have to have a plus 1 over in this factor, minus 1 in this one. So that way I'd have positive 6x minus 1x giving me the positive 5x, and then negative 1 times 1 gives me the negative 1. Okay, now I have what I want, a product equal to 0. And the only way a product is equal to 0 is if one of the factors is 0, right? So that's that 0 product property, right? By the 0 product property, either this factor, 6x minus 1 equals 0, or this other factor, x plus 1 equals 0, and then solving each of these, you get x equals 1/6, x equals negative 1, and here they are. And you can check them if you want. Be sure to check them to make sure that they do make that polynomial 0. But these are the values I couldn't plug into this fraction, because if I plug in either one of these, the denominator will be 0, and that's bad. But these are the values they want us to find, right? The values that make the expression undefined. All right, so positive 1/6 and negative 1. So x equals 1/6 makes it undefined, comma, negative 1. Right. And then submit. Right. Again, please read through the answer explanations. Okay, moving on. All right, now we're back to the objective simplify rational expressions. Same steps as earlier. I'm going to factor the numerator completely, factor the denominator completely, and I personally like to state the values of the variable that will make it undefined, right? The values you can't use for w here, and then cancel any common factors, and that'll really be it. And then this time I'll write the final version in factored form. Right? You'll see that they'll take that as well. Okay. So I'm going to go off to the side here. The numerator, 16w squared minus 28w minus 44. Right, there's a common factor, right? GCF of 4 here. So I'll pull 4 out. Then you'd have 4w squared minus 7w minus 11. And then this factors nicely. So we have 4, and then the 4w squared minus 7w minus 11. That would factor like this. You'd have 4w, w, minus 11 here, plus 1 there. That would factor to 4w minus 11 times w plus 1. And you can check by multiplying. Okay, so there's the numerator, totally factored. The denominator, negative 16 w squared plus 121. And the greatest common factor is 1, but you've seen me do this in other videos as well. When the lead coefficient is a negative number, I usually like to pull out the opposite of the GCF. I pull out a negative. So I'm going to factor out a negative 1. Really, I'll just pull out a minus sign, right? You could write negative 1 or just a minus sign. Right? And then you'd have 16w squared minus 121. And this is actually a difference of squares. 16 times w squared, that's 4w to the second power. Minus, and 121 is 11 squared. So I have negative 1, right, or again, just a minus sign as one factor, times, and then 16w squared minus 121 would factor to 4w minus 11 times 4w plus 11. All right. So I'll write all this here. Right? So this fraction we're given would, when you factor the numerator and factor the denominator completely, the numerator is 4 times 4w minus 11 times w plus 1 over, then this factor of negative 1 in the denominator, you could pull that out front of the fraction here, right? Negative 1, or multiply the top and bottom by negative 1, but either way you have a positive divided by a negative. That's going to make a negative result. So I'm just pulling this factor of negative 1 out front, in front of the fraction, which is a legitimate move. And the only other factors left in the denominator are the factor of 4w minus 11 and 4w plus 11. All right. Now I'll make a note here that w cannot be 11/4 or negative 11/4, right? Just keep that in mind. Because if w were 11/4 or negative 11/4, the denominator would be 0, and that's bad. That's undefined. All right. So now I do the canceling of common factors. Well, there's only one common factor I see, and that would be 4w minus 11. All right. So in the end, I have, the minus 1 out front, right? Negative 1 that pulled out front. Numerator of the fraction has 4 times the quantity w plus 1 left over. And the denominator is just a single factor, so no need for parentheses around it, 4w plus 11. And here's what I'll enter. And again, you can test this out. Replace w with any value you want, except for these two, right? Except for 11/4 or negative 11/4. And the value of the original expression should be exactly the same as the value of this final expression. And if you want, you could distribute the 4 up here, but I'm not going to. This time I'm going to type things in already factored. Alright, so I got minus, and then 4 times the quantity w plus 1 divided by, and you see how they pop that minus out in front of the fraction there. It's kind of faint, maybe 10. And then the denominator 4w plus 11, right? Just make sure you type it in the correct letters too. I've seen people get things marked wrong because they accidentally put X instead of W, or a letter that wasn't actually in the problem. So yeah, so see, they actually multiplied out, made that 4, the opposite, the opposite of, and then the numerator is 4w plus 4. But as long as what you enter is a simplified fraction, right? The numerator and denominator don't have any common factors. You can write it in factored form like I did, and as long as it's equivalent to what they have, they should be marking you correct. All right, and again, please read through the answer explanations. Okay, next question. Same objective here, simplify rational expressions. So once again, I'm going to write this out. We'll factor the numerator completely, factor the denominator completely, and cancel any common factors. And I will also state the values of y that aren't in the domain, that can't be used. All right, that would make the denominator 0, make it undefined. All right, so once again, I'm asked to simplify this. Now the numerator, 8y cubed minus 125, this is a difference of cubes. This is 2y to the third power minus 5 to the third power. So, and again, I'm assuming you know how to factor, right? We have a difference of cubes here. 2y cubed minus 5 cubed would factor to, one factor would be 2y minus 5. The other factor would have 2y to the second, so 4y squared, plus 2y times 5, so 10y, plus, and then 5 squared, or 25. And this quadratic you can check using the AC method or do the b squared minus 4ac check. This is not factorable. All right, so this is as factored as the numerator will get. The denominator, I got 12y squared plus 2y minus 80. There is a greatest common factor here of 2, so I'll pull 2 out. And then you'll have 6y squared plus y minus 40. All right, and then we try factoring this polynomial here. All right, so we have 2 times, and I'll factor this. Again, you can use the AC method or guessing and checking, trial and error. But I'm going to tell you right now, I can see how this will factor. Alright, because 3y plus 8 times 2y minus 5, that'll give me the 6y squared. Then we have minus 15y plus 16y would be plus 1y, and then minus 40. Okay, so I'm going to rewrite the fraction now. Numerator totally factored. We have 2y minus 5 times 4y squared plus 10y plus 25. Divided by, and then the denominator factors are 2, 3y plus 8, and 2y minus 5. Okay, and then again off to the side here, I personally like to state the values that make the expression undefined, the values you can't replace y with, that make the denominator 0. Looking at each of these factors, if y were negative 8/3 or positive 5/2, right, then this expression would be undefined. So later, if I were to test some values of y, I can replace y with anything I want except these two numbers here. Alright, now the cancellation of common factors. 2y minus 5 is the only common factor I see, so I'll get rid of those. Those become, remember, they become 1. So that's why I say they disappear, times 1. The numerator has only one factor, so really no need for parentheses on that. 4y squared plus 10y plus 25 in the numerator. And the denominator has these two factors left, 2 times the quantity 3y plus 8. And this is totally fine right here. And you can enter this, just make sure all of that's above the numerator bar, above the fraction bar, and all this is below. So yeah, you can enter things where everything's factored, or you can actually multiply stuff out, right? The numerator 4y squared plus 10y plus 25, and then actually multiply the factors in the denominator to get 6y plus 16. And this is equally valid. They are the same expression. And then once again, if you wanted to test it, test out, is this original expression actually equal to this final one? Test some values of y. Replace y with 0, 1, 2, 3, whatever you want, -5. As long as it's not -8/3 or +5/2, and the value of the original expression should be the same as the value of this final expression, however you have it written. Alright, so this time I'm going to enter the multiplied one. It really doesn't matter. As long as what you enter is equivalent to the answer they have, they should give it to you. Alright, so again, in parentheses, the numerator 4y squared plus 10y plus 25, close parentheses, divided by. Alright, now, again, the reason I put it all that in parentheses is so when I hit the divided by the slash button, it all goes in the numerator. Right? Then denominator 6y plus 16, right? Or 2 times 3y plus 8. And I'll leave the parentheses this time, it doesn't matter. Right? Great. Alright. Next question. Please read your answer explanations. So once again, looks like it's going to be the last question in this. Simplify this fraction, this rational expression. And this time it involves the variable q, right? And at some point after factoring, right, I'll put the values that q can't be, right, values that make the denominator 0, and then we'll simplify. Alright, so this one I'm going to go rush through a little more quickly. The numerator is a sum of cubes. That would factor to 3. Again, I'm assuming you know how to factor, so this would factor to 3q plus 2 times 9q squared minus 6q plus 4. And I leave it to you to check that. And then this is not factorable, this 9q squared minus 6q plus 4, so that's as factored as this gets. Denominator is a difference of squares, would factor to 3q minus 2 times 3q plus 2. And we can see now after factoring that q cannot be replaced by 2/3 or -2/3. Right, but anything else would be fine. And then canceling common factors, I'm seeing the common factor of 3q plus 2 in the numerator and denominator, and I'm done. Right, the numerator, the only factor left is this 9. So since it's the only factor left, I don't need parentheses around it. 9q squared minus 6q plus 4. Denominator, and again, the only factor left, so I don't need parentheses around it, is 3q minus 2. And this is what will be entered. And again, if you want to test it out, test some values, replace q with any value but 2/3 or -2/3, and the value of the original expression should be the same as the value of this final one. Alright, now let me show you what happens when you don't put parentheses around the numerator here. 9q, if I just typed in the numerator, 9q squared minus 6q, and then plus 4, and then I hit the division symbol, see, it only puts that last term in the numerator. I want the entire thing in the numerator. That's why I'm putting parentheses around it. Okay. Now it's all in the numerator like I want, and then the denominator is 3q minus 2. And again, this, and you can erase the parentheses after if you don't like them, but it should be fine to keep them. All right, great. So done with that one objective. All right. Simplifying rational expressions, you factor the numerator, factor the denominator, cancel any common factors. It's simple as that. So obviously the key is to know how to factor. Alright, then the last 2 questions, I believe, and it looks like I probably only have 2 more, is going to be the determining which values make the rational expression undefined. And if you recall from my 2 questions on this objective earlier, it means we're only focusing on the denominator. So we have 8q plus 8 in the numerator, and then 3q squared minus q minus 14 in the denominator. And all we need to find are the values of q that make the denominator 0. So I'm not going to write the entire fraction this time. I'm just going to write the denominator equal. When is that equal to 0? And we'll solve that equation. And those will be the values that make the expression undefined, make the denominator 0. All right, so here's again the denominator of that fraction. We want to know when is it equal to 0. And I'm just going to factor it. Now, I'll tell you, again, you can use the AC method, guessing and checking, trial and error, same thing as guessing and checking. This is going to break down to 3q and q here, and then I have to have minus 7 here, plus 2 here, right, to make 6q minus 7q would be minus 1q. Great. So, and then by that zero product property, we have a product equal to 0 here. The only time a product is equal to 0 is when one of the factors is 0, so either 3q minus 7 equals 0 or q plus 2, the other factor, equals 0. And then solving these gives me the values I'm looking for. So q equals positive 7/3 or q equals negative 2. And check them, make sure that they're actually making that denominator 0, and they should. So these are the values I'm looking for, 7/3 and negative 2. And those are the values that I can't plug in for q because they would make me divide by 0 and make the expression have no value, be undefined. But 7/3, comma, negative 2. Okay, and then one more like this. Again, please read the answer explanations. And then one more like this. Once again, we're given a fraction, a rational expression. We're asked to determine, which values make the expression undefined. In other words, which values make the denominator 0. So once again, I'm just going to set the denominator equal to 0, and we'll solve that equation. Okay, so here I've taken the denominator of that expression. When is it equal to 0? We're solving this equation. One thing I'm noticing here is that all these coefficients are multiples of 4. So if I want to make this equation have some smaller numbers, I'm just going to divide everything by 4. So this would be 21n squared plus 19n plus 4 equals 0. Great, so numbers are a little smaller now. And now I'm going to factor this polynomial here. Now again, you can do the AC method, trial and error, whichever one you want. AC, 21 times 4, that's 84. And then 7 and 12 are factors of 84 that make 19. So I need 7 and 12 to show up here. So I'm going to do this. I can see it. Again, if you can see it, just write the factors. If not, you'd have to rewrite the middle term as 7m plus 7m plus 12n and then factor by grouping. Hopefully you remember how to factor like that. So 7 in here, 3 in there. I need plus 4 here, plus 1 here, right, to get 7n plus 12n for the set for the 19n. And then you get so that factors to 7n plus 4 times 3n plus 1. You can check by multiplying. So then obviously n equals negative 4/7 would make this factor 0, right? If you set this equal to 0 and solve, and then if you set 3n plus 1 equal to 0 and solved the other factor, you'd get n equals negative 1/3. Right, so those two values, and again, don't forget to check them, make sure that they make it true, but I'll leave that to you. So negative 4/7, negative 1/3, those are the values that I couldn't plug in for n in this expression. Because if I did plug in negative 4/7 or negative 1/3, the denominator would be 0, and this expression would be undefined, have no value, and that's no good. Right? So n equals, negative 4/7 will make the expression undefined, comma, negative 1/3 will also make the expression undefined, the denominator 0. All right, and that's it. All right, great. And that should be the end of my version of the assignment. And as I said at the top of the video, right, the version I'm doing in these videos isn't necessarily going to be exactly the same questions, the same version that you're going to see when you work on it on your own. But the objectives are the same, the types of questions are the same, the way the way you should do them would be similar. So again, hopefully watching me go over these helps you in some way when you're working on the assignment on your own. And thank you very much for watching.